Sorry. Is it
Oh, it's good.
okay? So okay, I'll close it and take it.
Thank you, Horace.
Oh, no.
See. Probably.
Okay, Friday. Yeah. Oh,
Nice here. Okay, good morning, everyone. I think we can get started. In today's lecture, week 5, we will talk about SQL, which is short for statistical SQL, structural query languages. It's a very, very powerful database language. In the past few weeks, we have learned about the SAS skill sets. The proc SQL is a database language that allows us to sort the data, summarize the data, and the subset data, and also do the merges. join the tables in just one steps simultaneously. It's a very, very powerful skills. A powerful data step procedure that allows us to do all those functions within just one step. Now, for today's content, we will talk about the basics syntax of PHAD and what are the basic required components as well as the optional components, I would say statements in the PHAD. And in the second part, we will focus on how to use PHAD to summarize data, basically what can be achieved using the group by statements. And lastly, we will focus on which is one of the most commonly used of PHAD, that is the join, different types of join that can be achieved in a PHAD. It's kind of comparable or similar to what we have learned for the merge statements, SAS merge functions. Firstly, we need to understand what are the basic syntax order in order to submit the queries to SQL. It's very simple. So PHAD procedures consist of the several components. First, if you want to do the PHAD, you have to start with the PHAD and then semicolon. And this coding ends with a quit and semicolon. Remember, we have learned about the basic SAS. It ends with run and semicolon. So for PHAD, it ends with quit semicolon. And between the PHAD semicolon and the quit semicolon, there is a multiple statements you can write based on the needs. It's really straightforward, this code. And paying attention in this statement, all these types of statement, there is no quotation. There's one semicolon after all the types of statement. Okay. And we will start with the mandatory statement. We will start with the required statement. It's in all the PHAD. Besides PHAD and quit, in between, you have to write select from. Those are the two required statement. And I will tell you that to understand these two, just when you do the PHAD, just ask yourself what variables, what columns do you want? Which when you have that understanding, then you put them after the select. It basically select variable 1, variable 2. The object item is just variable items or column names. And ask yourself another question. What source of databases that can provide these variables of interest? Those variables of interest. So from is from a list of databases or from list of data sets or data sources. Just ask yourself these two questions when you write PHAD, and then this is the required component. Now I want to pause here just to move to the SAS Studio. Just give you a very simple example before going into another optional statement. So I want all of us to go to the SAS Studio. Let's open the week 5 code. So basically, I want to show you a very simple PHAD. Let me just run this. So there I will demonstrate using 2 data sets today. So the first data sets that we're gonna use during the class is called DOB. So if you look at here, this is just a very simple data sets. It has 5 rows. So 5 patient ID. And with each patient ID, we have the band ID, which is 1, 2, 3, 4, and 5, and date of birth. Okay. So I just want to use Proc SQL. Maybe I just want to visually see the band ID and date of birth. What I can do is just Proc SQL and then select these 2 variable name. These are the 2 variable that I want to include, right? So it's just band ID and DOB, which is the first question I just mentioned. Ask yourself, what do you want? What variables do you want in the final data sets? These are the 2 variables. And then I mentioned the second question is you ask yourself, where can they come from? Where does what is the data sources that can provide you these variables of interest? Basically, it's class.band DOB, which is the data set's name. Okay, it's really simple code. So this is the basic of process SQL. So let me just run it, and you will see it just. Let's see the log. Log looks okay. You will just see the band ID and DOB. This is the basics of Proc SQL. And another examples that I want to us to understand is I also want to mention when we have the select from, it allows us to select either 1 variable, 2 variables, or multiple variables, or all the variables. If it is just 1 variable, 2 variable, many variable, you can just list off them. And if in the cases you want to select all variables, there's efficient way to do is just to have asterisks instead of list all the variables. You just have the asterisks. So let me open this another data sets, which is cars. I believe we mentioned this data sets before. It is in the SAS help library. If you click the SAS help, there is a data set called cars. You look at here, there are more than 400 observations and 50 variables. This has model, type, origin, different variables related to cars. I want to use these data sets and I want to visual all the variables in a table. What I can do is, of course, I can just select make, like type, I can list all of them. But like I said, there's another efficient way, just as there is. If you run this code, pay attention, we have the select asterisk, means all the variables. From is the data source that we are into, the data source that provides all the variables. It says help.cars. So let's just run it. You can see now we have, we can visually see all those variables in this cars data set. This is an efficient way we can do is just have asterisk to select all the variables. And of course, we can just select model and type if we are just interested in these 2 columns. I want to mention in Proc SQL, the language is a little bit different. In Proc SQL, we usually call it columns when we refer to variables. But in SAS, we usually refers to variables. And in Proc SQL, we create a table. In SAS, we usually call like it's a data set. It's just the language is a little different. Now, okay, let me run this code again. Now, we visually can see that there are model and type 2 columns in this table. I'm gonna move back to the slides. It's really like we just see select from. Those are the required statements. What are the other optional statement in the proc SQL. There are actually 4 of them besides select from. So can you see the slides? Side.
I can, Dr. Huang, can't see the slides.
Okay,
I can't see
great.
the slides. I'm sorry. I can only see your code.
You see my code on the slides?
I can see the code, not the slides.
Okay, I need.
Before I did see the slides, but now I cannot.
Okay, thank you.
Oh, now I can, yes.
There are 4 other optional statement here. I apologize. This table is a little busy. After select from, we can have where statement, or the group by statement, or the having statement, or order by statement. I forgot to mention at the beginning, in order to remember all those orders, this is actually in a, how to say, we have to write them in exactly this order, and we will talk about the details, but those orders are the exact order which we highly recommend. So there are Dr. Ramchandra and other researchers, they come up with this: so few workers go home on time, which refers to select from, where, group by, having, order by. It is help us to understand orders. Like I said, we have to always really recommend to abide by these orders. Otherwise, they may encounter some errors. So now back to those optional statements. Let's start with the where statement. We have all learned about where statement in SAS, and actually this is a very commonly used statement in different programming languages. So remind me what a where statement in SAS about. Anyone remember where statement? What does where statement tells us in SAS? Basically tells us to filter the rows, right, with some conditions, right? It's same with what we have in proc SQL. Where statement is filter the data based on the condition. We can have like where in the cars example, we can have like where the make equals Camry, or where in the band ID, like where the band ID equals 1 or 2. So where statement help us filter the observations based on a particular conditions. We will talk about group by in the second part of the lecture because it requires more discussion. This is help us to summarize the data. And actually group by usually comes with having. There's slight difference between having and where statement. We will use some examples to demonstrate the difference, but where statement, having statement, their function is the same. But where statement usually refers to the original variables in the data set, but having usually deals with the post group by variables. It's the variables that we created. But those 2 statements all help us to filter data. It's just to have a subset of data or filter the observations. And order by is usually the last the last step that this proc SQL will perform. It helps you just after everything, select from where, group by, and having, order by, just arrange your data in an order. So what this, generally speaking, what this proc SQL will do is they will first read the from table statement, and from there they will continue read the where, group by, having. They will perform this, and then it's first from, and then the select. Okay, it's first from, and then where, and then group by and having, and then select, and then order. So order is the last step, and of course from is the first initial steps. After from is the where, because they can only select variables from a subset of data if you have the where statement. And then it's grouped by having. Followed by that is select, lastly is ordered by. Those are the, you want to say the what they will perform in the back. Okay. Now, I will quickly use some slides to demonstrate, and then I will move to SAS Studio. It will become more clear to everyone. These slides just demonstrate to you how the different languages in SAS and PHAD. In PHAD, we have shown you it's about the select statement, where in the SAS it's have the drop statement or keep statement. And in the PHAD, when we talk about later, when we want to rename the variables, we just have the as, where in SAS is the rename statement. And I also want to highlight is the PHAD and the SAS, they all have the where statement to filter observations. Interestingly, in the PHAD, we usually use the distinct if we want to the unique patient ID. In the SAS, we will cover maybe in the future is about PHAD sort non-duplicate. And like we mentioned in SAS, we call it data sets. So it started with data statement. In PHAD, we use this statement create tables. We will show them in a quickly shortly. It's create tables that help us to create a data set, create a new table. And there is an order by for PHAD, whereas in SAS PHAD sort. Okay, we will show most of those steps in SAS Studio today. And those are different terms we can use in SAS and SQL. Very shortly, we will demonstrate that the very basics of PHAD, it's the select the specific variables. Actually, we have already demonstrated before. And we will then quickly show you how to use where clause to filter the number of rows. And we also already show the select all variables from data sets. And we will also then show you how to sort the data using the sort statement, order by statement, and how to create a new variable use the as statement.
In the previous slide, on that progress fields, select a case choice where is performing two functions, drop column and also to display the outputs. Under the progress field column.
This slide?
Yeah, this one.
Okay.
So you can see select function appears first time where is performing the function of dropping a column. And then second to the last row.
Oh, plot print. Well, basically, we have just shown you that the basic of select from. When you do just the select from, it's just print out these variables that you include in the select statement, right? There's no there's no separate plot print, something like that. But when you do the select from, basically print out the variables. Okay, this one we have just shown you is just select specific variables. And how to filter number of rows based on a condition using where clause. Here is examples that we subset of data based on the conditions specified in the where clause. Now, I want to move to SAS Studio to show you how we can filter the number of rows based on the condition specified in the where clause. And before that, I want to remind you which I also mentioned before, is about the semicolon, all those quotations. see here, select variable 1, variable 2. I'm sorry, select variable 1 band ID, and there is a quote here, another variable 2 from this data sets where all in between there is no quotations. I highly recommend you just put them in different lines for you to understand its different steps, but there's no quotation. And only until you finish this so few workers go home statement, like select from where all those statements, you have a semicolon, and then you have a quit. Okay, you will get familiar with this format when you have more practice. Now I want to move to the SAS Studio. In the basics, the where clause is one of the very commonly used one, because a lot of times we just want subset of patients. Maybe we just want those whose age is above 80. We just want adult patients. So we can specify where age greater or equal to 80. Now here, in our basic examples, we just want the patients whose birthday is who are older, whose birthday is above January 1st, 1990. If you look at first, in the class DOB, we have 5 patients. Let's see here. DOB is here. Here we have 5 patients and their date of birth from 1982 until 1990. So it's a wide range of ages of those patients. And if we just want to, the younger patient, DOB greater than 1990, January 1st. So we only print one record, one patient ID, right? So this is called the filtered rows or filtered observations, correct? And the 4 patients are dropped. Okay. This is the where statement. Another example for where statement is in the CARS examples. If we look at this, the CARS data sets, I remember we have like 428 observations. If you look at here, the CARS examples. We have different types of car. We have SUV, we have sedan, we have sports wagon, different types of car, and truck. If we just want SUV car, what we can do is we can put where type equals SUV. Can just see. Now we only have the type where it is where the type is SUV. And we also know in the where statement, like in the SAS, when we write where statement, we can have Boolean operator. We can have and or. So we can, same here, when we have the where statement, we can where type equals SUV and weight more than 5,000. You can use Boolean operator to write as many conditions as needed. Let me just run this. You can see we have SUV and also at the same time, the weight is more than 5,000. After talking about where statement, the base question is valid that if we just have select from, all we have is just print. If we want to create a new table based on the variables that we included in the select, we have additionally have this statement, it's create table, new DOBS. This is a step that kind of like the data steps in SAS, which allows us to create a new data sets here. Create table, new DOBS. Basically, it's like data DOB underscore DOB in the SAS statement. Please be familiar with this how to say this language, create table, and this is the new data set's name. And there is the S here. Okay, now let's see what we will have. And we have the select from, which are the required statement. And then we also have the where clause that's only subset part of the rows. If you look at here, let's see the log. The log said the table new DOB created because you have used the create a table as. So this compared to what we have done before previously, this when we have this one, we created a new data set. We created a new table, and this table has 1 rows and 2 variables. Now I will quickly move back to the SAS, back to the slides. In addition to the where statement, we also have we also can sort the data using a order by statement. This order by statement is really similar to what we have learned in a SAS proc sort. And this order by statement can also have the, if you want to choose ascending, descending, based on you can write the ASC or the DESC. And it's gonna return you the table in a sorted order. And like we mentioned, is the last statements that the proc SQL will perform basically at the select from, where they will just rearrange your data in a orderly. They will order your data. And I will demonstrate it shortly. I also want to kind of proceed to finish the basics in proc SQL in the slide. We can also create a new variables. Like in SAS, we can create a new variable. In the proc SQL, when you create a new variable, it's really straightforward. It's embedded in the select statement. You just need to do row. This is a new variables. You just have the AS. So there is a new variables created. And DOB, if you want to rename it, you also can write it DOB as DOB new. So it is same as in SAS, rename DOB equals DOB new. So the AS is powerful. It's kind of like rename function, or like the create a new variable function. And you may also notice that when a new variable created, we name it as age. This is calculated based on the existing variable, the DOB. Okay. And now let's move on to SAS Studio just to demonstrate the sort the data as well as the create a new variable in SQL. Like we have shown that the class dot band DOB, we have 5 rows and 2 variables. I wanted to view this table of this data set so that the variable data births is arranged in a sorted order so I can see what are their data births range from. So all you have to do is to have the order by with this variable here. So if we look at here, now the data birth is listed in a sorted order from 1982 January until 1990. And of course, we all know that right now it's the ascending order. I'm sorry, descending order from the largest value to the smallest value, right? Of course, this value is the larger value, 1982 in
I think it already was like sending was
okay, ascending order. And if we want to have them the reverse one, we can put the descending DSC, yeah. We have just mentioned we can also create a new variable using the AS function. So now let me run this. Because remember in the prior exercise, we asked you to create a new variable named age based on their existing variable DOB data birth. So we have them here in a one steps in the select statement. If you look at here now, the age is presented in a sorted order, and we additionally have, the age is calculated based on the existing variable DOB because we use the year different function, right? And we also have a newly created variable named DOB. Okay, those are the basics of proc SQL. I want to move to a second part is summarize data in ProcSQL, which is also powerful functions of ProcSQL. Remember, in SAS, when we actually have not taught too much about the summarizing data. There is the proc_freq. We have just we know we can use proc_freq. We can use proc_means. There is also proc_univariate, which we may talk about in the next Monday's class. In SQL, there is function. There's a statement. I would say statement. It's called group by. This group by statement can help us to aggregate or summarize the data. We will show you different summary functions shortly. When we want to summarize the data, we have to write group by a certain variable. This usually is like the patient ID. If we have the visit data, if we want to just to have the patient's the example we talk about it in the exercise last class is like patient's first prescription date or the last prescription, the maximum prescription date or the minimum prescription date or the total number of prescriptions. All those variables or the function can be achieved just using a group by, and we don't need to sort the data when we use ProcSQL. When summarizing data, like we mentioned, we have to have the ProcSQL along with group by. This is one example I want to demonstrate just to let you, I guess most of you already understand, but I want to reiterate what does mean by summarizing data. I give you a very simple examples. We have this data sets. It's a band ID, visit, cost, and different diagnosis. This is a visit level data we will encounter in the claims data. It's the patient event data. So you already know, like the patient one had 3 visits from February 2016, 2010, and then the next one is August 2010. Third one is December 2010. And the patient 3, ID 3, also, the patient has 4 visits, and we have not patient ID 1, 3, 4, 5. We have 4 patients. This is called event data. When we talk about summarizing data, this is the resulting table I want us to create it. Is I want to have the patient level information. I want to have the patient's first visit date. I want to have the patient's last visit date. And I also want to know what are the total, maybe the hospitalizations for the patients. This can also be a pharmacy claims. We can have patient's ID, and visit can refers to different prescription date, right? There is a different cost associated with that prescription. Maybe I want to know the patient's first prescription filling, the last prescription filling, and what are the total prescription filled during this period, and what are the maximum cost that the patient paid during all the prescription fill, the minimum cost, or maybe the average cost during all the prescription. If we want this kind of information, we call it's a summarized table or summary information. Okay. Those we can achieve just in one set of coding in PHAD.
For the second row,
Mhm.
table,
Uh-huh.
patient A, I think there is an error with the posts. The main visit,
Uh-huh.
it says it's 23rd July 2011, but from the data set is 15th October 2009. So I think it's a typo.
Oh, okay, yes. I did not know this. Thanks, Ben. Yeah, should be October 2019. Yes, this is the first date. Yeah, thank you. If we want to summarize the data, we just mentioned in that example, we just need to use PHAD, and in this PHAD, the red, those highlighting the red are the group by the patient ID. And in the select, you just need to have the different summary functions. And the minimum, maximum are the summary function and very commonly used. And we can also have the count, right? So the minimum visit, we can have it as the first visit, and maximum visit, we can have it as last visit. And we can also by the format here, gonna be then the date will be formatted in the date night dots formatting. And we can also have the count visit, basically gonna help us to count the frequency or the total number of visits. And in the language here, we can consider the event level data, the different patient ID as a bucket. So the group by is the bucket variables here. What we have is band ID. And like we mentioned, there in the PHAD, the count, minimum, maximum, sum are very, very commonly used summary functions. This can be translated into the base SAS, the PHAD means. We will talk about that next Monday. And there is a list of summary functions. And I want to mention that I want us all to know, or be familiar with the average and count, and SUM is the summary. And max minimum is the largest value, the smallest value. And we have STD is the standard error. And those are the what I just mentioned are the very commonly used summary function. And I think it's really straightforward to us. It's like the languages, right? Like the maximum, minimum, sum of all the languages. So I will move to the SAS studio to demonstrate how we can use the summary function. Or we can call the group by statement. Before that, I just want to show you the band visit data. We actually have demonstrated in the slide. The band visit data have the data has 53 rows, 53 visit events, and there are 30 total variable columns. And we, like we mentioned, we want to summarize the each bucket or each patient ID, first visits and last visits, and also their total number of visits. So we just write the code as, of course, we start with the new table name, create table. We call it new visit as. It's actually create a new data set name. And we use the select from. Select. In the select, we mention the different summary functions, minimum and maximum and count, right? We can count the visits as the number of visits. And we can also count the distinct visits and number of distinct visits. Of course, we have the minimum visits, first visit, maximum visit, and last visit. And we need to specify the from, where, what is the data sets or the data source we want those variables select from. And very, very importantly, when we do the summarizing data, the group by is grouped by the variable, which is the bucket variables, right? So when we have this group by, then the final data sets will be presented as different unique patient ID, different distinct ID. Now let's us to run this. Let's see the log. Okay, the log tells us this walk new visit created with only 50 rows. Before we have like 53 or 54 rows. Now with this new table, we only have 15 rows and 6 columns. We can see that this is actually it becomes a unique patient ID data, level data. And in each row, each unique patient ID, we have its first visit and last visit. What you notice, the first visit is just a SAS numeric values because we forgot to have the format there. We need to adjust them. And the last visit is formatting the date 9, which we want. And we have the number of visits. So basically the first patient during the time have total number of 3 visits. And there is a distinct days, also 3. We can also additionally, if we specify the first visits, we also need to format the first visits. Just for me. If we format here now, it looks fine. And log still mentioned 15 rows, 6 columns, and first visit and last visit. Now we can see, and this is actually help us to kind of the word read across rows. So we can, in a unique patient ID level data, we can have first visit day and last visit day. And it seems to us the number of visits, the number of distinct visits, the same number. It because like each patient's different, their visit day is different, is unique. So the unique days, the total number of the unique visit days, same as total number of the different days.
So I have a question.
Uh-huh.
So in this situation, we selected for some particular variables. So if you look at the data set, you can see, for example, patients with beneficiary ID1,
Mhm.
when you presented those 3 times, had 3 different diagnoses. So in selecting for a distinct Benny ID, how does that, assuming we were not dropping those respective diagnoses,
Okay.
even though the Benny ID was repeated 3 times, how does
Yeah.
that adjust for the fact that they might have been repeated at the Benny ID level,
Mhm.
but there were different diagnoses
For each day.
for each day? How
Yeah.
how does that?
This is a good question. It's same as when you have different days, different prescriptions. What you will do in your project is you're gonna first identify your diagnosis of interest first. You may use those, it's beyond the topic here right now, but you may just keep the diagnosis, for example, diabetes or diagnosis of cancer. You can use if then statement. If then delete or like if keep. That clear?
So in that regard, it's not possible to really get a distinct Benny ID. It's not possible for us to select for distinct Benny ID since if you're using a continual treatment diagnosis. So, I mean, if we are selecting for a particular diagnosis, it's only going to reflect rules that contain those diagnoses.
If that is the question that you are interested in.
Yeah.
Yeah, if this question that you are interested in, like you just want to know the dates, visit date associated with the patient diagnosed with diabetes, then you have to do that first.
Okay, so I guess my question is like I want to know if these 2 things are mutually exclusive in the sense that if a patient presents 3 times.
Okay, let me move on to the original data set.
Yes.
So everyone understand what your question is. This is a data set we have, in this fake data sets, we have 10 diagnoses.
Yeah.
And each time it may be different or same.
Yeah, so take for example, Benny ID1, which occurs within the data set 3 times. We scroll to the right, you can see that for the first visit, you have sickle cell anemia, second visit, sickle cell anemia, third visit for diabetes.
Yeah.
So we select for distinct Benny ID naturally, and we chose to drop the columns that contain diagnosis. It won't give us, and there will be no issue in that regard.
Yeah.
My question is, assuming we did not drop the columns of diagnosis,
Okay.
when it selects for distinct Benny ID, so
Yeah.
the output will give us 1 row for
Yes.
1.
Yes.
So how
Yes.
does that take care of the different rows of diagnosis?
Got it. Yeah. Yeah. That's a good question. um. This is something maybe we have to handle before, like, maybe we just want the diagnosis of interest first, or, um. Or we can maybe have a summarized score to have all the diagnoses. Though, those are something we have to handle, or we have to manage that first.
Or we can also select for the diagnosis too. So in that regard, we might not necessarily get one rule for Benny
Yeah,
ID, but we will get best summary we can get in terms of both at the level of the Benny ID and at the level of diagnosis. So if there is any repetition, for example, we have two sickle cell anemia
yeah,
at the level of diagnosis one, those two will be collapsed into one.
correct.
Meanwhile,
yeah.
the diabetes will remain as its own role simply because sickle cell anemia and diabetes are not repetitions. So we have two rules for Benny ID1.
Well, Ben, to be honest, we have to manage this data sets a little bit because the diagnosis 1, 2, 3 for SAS is, how to say, we better to have to manage that, the diagnosis first. Like, we have to define, usually maybe we have to only subset a diagnosis of interest and then go from there. Mhm. Mhm. That's a good question. And I would just want to quickly mention what we will have to do is, if you notice, everyone, including Ben, if you notice here, let me just make this answer very short. If you look at here, diabetes can occur in DX1 or DX2, right? Or maybe DX3. It does not matter because it is just any diagnosis of that is diabetes. What we will have to do is we will create a flag variable. We will, like, use an array. Long-term story short, we will use array to create a flag variable. So there's a flag variable showing diagnosis 1, 0, or 1. Binary variable for diabetes. And from there, we can use PHAD to get those with diabetes or not diabetes. Or maybe we can convert this diabetes into a patient level data. Otherwise, we cannot just use all this, how to say, it's really messy. This is many, because how to say, vertical and horizontal diabetes can occur. We have to use the array to create a flag variables. And then we can convert them just visit level, just a one diabetes, yes or no variable. And then convert the visit level into patient level. This is how we're going to do with the diagnosis. Hope that helps you to understand. But I think this is good observation. But the distinct band ID here basically just, if we just want to calculate total visits and convert them into the patient level. But for diagnosis, we have to take extra steps.
Thank you.
Sure. I want to pause here. Let's have maybe 10 minutes break. Is that okay, everyone? And then we will come back to continue to talk about merges or join. I'm gonna pause the recording here.